But we're still not done, because we haven't figured out the units for k. So let's talk about how to do that. Well, what are the units for the rate?
Moles over liters times seconds.
Yeah, in fact, I guess they gave us the units in the table, right?
Yeah.
What units did they say it was in? It was in moles, liters -1, seconds -1. You guys know what these -1 exponents mean? What is it?
1 over.
Yeah, so this is really moles over liters over seconds. That's what the -1 exponent means. It means 1 over. This is a common notation at this point. What does moles over liters mean?
Molarity.
That's molarity. So this could also be called molarity per second. Well, that should make sense because the rate tells us how quickly the molarities are changing. It might be changing at 5 molar per second or 0.2 molar per second. So these are logical units for the rate. So rates, I guess, are always in these units. These are always the units for the rate. I think usually it's going to be better to not use capital M, but moles per liters. Now, how about what's the concentration? What's the units for NH4 plus?
Molarity.
Yeah, molarity or moles per liter. And what would be the exponents here? Well, because this is a 1, this would have an exponent of a 1, and this would have an exponent of a 1. But if this had been a 2, this would have an exponent of a 2, and this would have an exponent of a 2. So we have to use the exponent to get the right units here as well. So this is maybe not quite as obvious as it might have seemed. So what should be the units here for NO2 minus?
The same mole.
Yeah. Oh, yeah, that's right. And you know, maybe I can make my life easier here by calling this moles. I don't know. If I wanted to make it mesh like this, I could write it like this instead. So those are 2 ways, whichever you find easier. And this is the same, moles per liter, and the exponents here are just 1s. That's more confusing than it's worth. Let's write it like this. Okay, now what we want to do is find the units for k. Well, first of all, I can simplify the right-hand side. The right-hand side now is moles squared over liters squared. Moles times moles and liters times liters. Now, how can I get k by itself? Multiplying by the reciprocal. That's right. That's that way to get rid of a fraction, multiply by its reciprocal. This will get rid of the fraction from the right-hand side. What we're trying to do is solve for k. So this is a method for solving for units by plugging in the other units in the equation. And now I can do some simplification on this side. What are we going to have left on this side of the equation? So we have to see what did we get on the left-hand side here now? So let's write down what you would get from that. Right, okay. So one of these moles cancels, and that leaves us with 1 mole in the denominator, not the numerator. One of these liters cancels, but that leaves us with 1 liter on the numerator, and there's still seconds in the denominator. All right, or we could rewrite this as liters moles -1 seconds to the -1 power. Okay, so now we're ready to write the true rate expression. our rate expression is going to be 2.7 times 10 to the negative 4 liters, moles to the negative 1 power, seconds to the negative 1 power, times the concentration of ammonium to the first power, times the concentration of NO2 minus to the first power. So that would be the full rate expression. So until we find the rate constant, we haven't really found the full rate expression. Now, suppose I asked you, what's the rate going to be if the concentration of ammonium were 0.5 and the concentration of NO2 minus were 0.4 molar? How can we figure out what the rate would be with those concentrations?
Can we just use that rate expression?
Yeah. Now, that's the whole point of having a rate expression, right? The point of having a rate expression is now it makes it easy to find the rate for any pair of concentrations. So we might as well get a number for that. Let's work that out on our calculator. Good. What did you get?
5.4 times 10 to the negative 5.
Good. What would be the units on that?
Moles over liters per second.
Because it's a rate.
Right.
Because it's a rate, it would have to be molarity per second, or moles over liters over seconds. You could also get those units by plugging in all the units into the equation, but I find that to be more confusing than it's worth. We just should know what the units for rates are. They're always these units. All right, that's the whole point why we like having rate expressions. It lets us figure out what the rate would be for any set of concentrations. Before, we could only figure out the rate for the 3 sets of concentrations in the table, but now we can figure out the rate for any experiment that we haven't run yet. So this is the practical use of this approach.